This is basically going to be the last thing that we do as far as getting ready for geometry, chapter 0 stuff. You will see this guy as pretty familiar. Like I always tell you, whenever I introduce one of these lessons, it's mostly going to be me going over it kind of quickly, and then the next day we will go over it a little slowly, so hopefully you understand. Although I don't think you need this slowly. This be Pythagorean theorem. I have a squared plus, wow, b squared, wow, the lag is really bad, equals c squared. I'm going to label things. I have to label you C because the longest side is always going to be C. I'll call you A because why the heck not, and I'll call you B because why the heck not. Now I plug it in. Instead of A, I have 2 squared, and instead of B, I have 1.5 squared, and I still have C for C squared. 2 squared is 4. 1.5 squared is 2.225, just 2.25. Add them Johns together, and you get 6.25 equals C squared. Is C all by itself? No. What is in the way? Squared, square root, both sides. And 6.25 is, believe it or not, 2.5. 2.5 what? Miles. So that's what C is. And I'm not even going to put C in my final answer because I don't care if it's C if I'm trying to answer this word problem. I'm going from James to Sarah's house. Or maybe I'm going from Sarah's to James' house. Either way, I'm driving 2.5 miles. I would walk 500 miles. That's a song from a band called The Pretenders. Or is it The Proclaimers? I don't remember. Look it up. I will be able to solve systems of equations and inequalities. Gross. Know the system, beat the system. That adorable little chubby-fisted baby. All right. Video time, baby. All right, systems of equations, we're going to solve that system by graphing. Remember, our solution to a system of equations by graphing is the point where the lines intersect. So we got to do this quickly. This line right here, I'm going to make it blue. Start at -2. +1 for a slope is a line that looks like this. The bottom line, I'm going to make orange. Start at 4, up 1, left 2, up 1, left 2, as many times as I can. Bam! Draw a line right there, and as I'm speaking and as I'm drawing, it looks like these two lines intersect at the point 4, 2, which means my answer is 4, 2. Bam! Look at that. Done in a minute with a second to spare. So systems of equations are going to look like 3 different types of things. The first thing that we're going to look at is graphing. Graphing is potentially the easiest one of them all. Potentially. And in a case like what you see here, it is going to be the easiest because if I want to graph something, I want things to have y equals intercept form, or y is in slope intercept form rather. And both of these are. So I'm going to label you red. And I'm going to graph this guy on the coordinate plane below in red. The way I graph it is I start out at 3 on the y-intercept. There it is. The slope is -5/3, so I can go up 5, left 3, 1, 2. Uh-oh, I can't. But I can go down 5, right 3. 1, 2, 3, 4, 5. 1, 2, 3, put a dot. I would try to go down 5 and right 3 again, but I can't. So the best I could do is just this measly little line right here. Boy, is that a bad job. I'm going to graph this one in green, which is my favorite color. I'm going to put a dot at -3. This has a slope of 1/3, so I can go down 1, left 3, right there. I could try to do it again, but I can't. Or I can go up 1, right 3, up 1. Look, 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 look. Those two dots are the same thing. Go up 1, right 3, ran out of room. Draw your line. The lines intersect right there at that dot that I am now making blue. Now, when you're solving a system of equations by graphing, yes, the graph is great, but the answer to any system of equations, whether it's by graphing or substitution or elimination, as SpongeBob might say, the solution to any system of equations is going to be a point. And in this case, it's a point where the two lines intersect, and they intersect at 3, -2. Bye-bye. All right. All right. All right. All right. All right. This is one of the ones that you might be a struggle. It just might be a bit of a struggle. Solving a system of equations by substitution. When you're solving a system of equations by substitution, it's a several-step process. Step number 1, make sure one of the equations is solved for one of the variables. In this case, the top equation is solved for y. So I'm going to put a little check mark next to it because that step is technically done. Step 2 is you take that information and plug it into the other equation. Y is 6x minus 11. Y is 6x minus 11. So what I'm going to do is I'm going to turn that y into 6x minus 11. So I'm going to write out the other equation. So step 1 was solve any equation for any variable, and the top equation was already solved for y. Now what I do is I substitute it into the other equation. So I'm going to rewrite the bottom of the equation. But instead of writing out y, I'm going to write out 6x minus 11. And then I'm going to finish writing out the bottom equation. What I did is I wrote out the bottom equation and I replaced y with 6x minus 11 because y is 6x minus 11. And now it's just a really painful distributive property problem that you've seen a bunch of times before. -2x doesn't get bothered yet. -3 times 6x is -18x. All right, -3 times -11 is positive 33. That's going to equal -7. Look, dudes, combining like terms. -2x and -11. -2x and -18x make -20x. So I have -20x, drop down to plus 33 equals -7. Subtract 33 from both sides. I get -20x equals -40. Without showing my work here, I know what I do next. Divide both sides by -20. And when I divide both sides by -20, -40 divided by -20 is going to be +2. Now, in the last problem, my answer was a point. That's not going to change here. I found x, but I have another letter that I have to solve for, y. If x is 2, then why don't I just make my life a little easy and take, if I have to find y, why don't I just use the equation that says y equals? So I'm going to write out y equals 6 instead of x. I just found out that x is 2. So I'm going to replace x with 2 minus 11. 6 times 2 is 12, and 12 minus 11 is 1. So my x was 2, my y was 1. My final answer is the point xy, or the point 2, 1. So if you're looking at that and you're like, oh man, That's a lot, and I'm not 100% sure I remember. I have like 5 or 6 videos on the YouTube where I solve systems of equations by substitution. Hey, good job, friends. Let's do another one. Yeah, I'm not going to watch that video. All right, so remember in the last problem where I said if you're doing systems of equations by substitution, the first step is to solve any of the equations for any of the variables? Well, we have to do that here. And in this case, I noticed that none of the equation, neither the top nor the bottom, are solved for either x or y. However, if I wanted to solve the top one for y, it wouldn't be that bad. So let me just rewrite out the top equation. This is me rewriting the top equation. If I solved that for y, it's a one-step process. I'm going to add 4x to both sides. Now the top equation is y equals slope-intercept form 4x plus 6. That was the top equation. Since I rewrote out the top equation, I can plug it into the bottom equation. So I'm going to rewrite the bottom equation, negative 5x minus. But instead of y, I just found out that y is 4x plus 6. So instead of y, I'm going to write out parentheses 4x plus 6, close parentheses. I rewrote out the bottom equation, and I replaced y with the thing I just solved it for. Now I'm going to finish writing out the bottom equation. Negative 5x drops down. Distribute the negative, that becomes negative 4x. Negative times 6 is negative 6. That equals 21. 21! Oh, look, like terms I can combine. Negative 5x minus 4x is going to be negative 9x minus 6 equals 21. Add 6 to both sides. So I have negative 9x equals 27. Divide both sides by negative 9. And x equals negative 3. So that's the first part. X equals negative 3. What do I need to find? Y. The way I can find y is I'm going to take the thing here that says y equals, move that over here, and I'm going to write it out, y equals 4x, but instead of x, I just found out that x is negative 3. So y equals 4x plus 6? No. Y equals 4 times negative 3 plus 6. 4 times negative 3 is negative 12 plus 6 is negative 6. So if x equals negative 3 and y equals negative 6, I get my final answer to be the point negative 3, negative 6. Gross. It's a lot. I never said it would be easy. I just said it would be a whole lot of fun. Let's do another, shall we? I have a feeling I'm going to move to elimination. Oh, I did. Wait a minute. No, I wouldn't do that. It looks like the same problem. There's no way I would have done that. There's no way I would have purposely made the same problem twice. That's wacky. That's whack. Elimination. If you're doing elimination, this is what you have to do. You have to make sure that everything is all lined up. So let me see. I have the x's all lined up, and I have the y's all lined up, and the equal signs are all lined up, and the regular numbers are all lined up. That's good news. Good news. What you want is you want one of your variables to have the same coefficient but opposite. What do I mean? What do I mean but same but opposite? Same but opposite would be 3 and negative 3, 5 or negative 5, 1 and negative 1. Or in this case, y and negative y. Oh my gosh, I already have. Okay, so the first thing I had to do is make sure everything lined up, and it did. Then the second thing I had to do is find a variable that the number out in front is the same but opposite. The y has a plus, the y has the other y has a minus. Now what I do is I add the equations. Negative 4x plus negative 5x is negative 9x. Ooh. Y minus y disappears. 6 plus 21 is 27. Hooray, my y's disappeared. And now it's just actually a really simple problem. Divide everything by negative 9, divide everything by negative 9, x equals negative 3. Okay, I feel you, but I have to find y. So let me clean up this mess up here. Let me clean up this slop. I have to find y. I will take the fact that x equals negative 3 and plug it into one of the equations up here. So did I do the top or the bottom? Let's do the top. Why am I doing the top? Because it's easier to find the y on top because y is almost all by itself. So if I take the fact that x is negative 3 and I rewrite the top equation to negative 4 times, instead of x, I'll write out negative 3 plus y equals 6. It's not so bad. You become positive 12, and y drops down, and you become 6. And you are minus 12 to both sides because that's what I'm supposed to do. And y equals 6 minus 12, which is negative 6. So I found my negative 3, and I found my negative 6, and my final answer is going to be the point negative 3, negative 6. So you might be looking at this and saying, excuse me, sir, but it seemed to me that elimination, or as SpongeBob would say, elimination, seemed easier. And in this case, it was. We did the same exact problem using two different methods. And in the same exact situation, we got the same exact answer. So this was the same exact system of equations. I solved that one by substitution, and boy, oh boy, was it a mess. And then I did it by elimination, and it was less sloppy, and I got the same answer. So if I give you a problem, like, use any method you want, it doesn't matter. As long as you do it right, you'll get it right. So let's take a look at this one. If I'm solving a system of elimination, or of equations by elimination, I have to first make sure that everything lines up. All right, step one's good because the x's line up, the y's line up, the equal signs line up, and the regular old numbers line up. Then what I need is two of the variables to be the same exact thing but opposite, and that's not the case. If I look at my x's, I have a negative 4 and a 4, or a regular x. So those are not the same but opposite. If I look at my y's, I have a 9y and a negative 3y. Those are not the same but opposite. But it's an easy fix. If I multiply the bottom equation by 4, then I would have negative 4x, and on the bottom I would have 4x. So that would work. Or I can multiply the bottom equation by 3, and it would do the same thing with the y's. And that's what I'm going to do because I committed and I wrote it out. So I'm going to rewrite the top equation. The top equation was negative 4x plus 9y equals 9. I decided that if I multiply the bottom equation by 3, I'll end up with 3x minus 9y, which is what I want, equals negative 6. By doing rewind. I forgot to multiply 3 to negative 6, so that should be negative 18. Silly goose, silly Mr. Parrish. This is good because now I can add the two equations. Negative 4x plus 3x is negative x, or negative 1x. You disappear,
and u become -9 if I add you two together. A little bit of common sense without doing any math. If negative x is -9, then positive x is +9, and I have x. So now what do I have to do? Well, I found x, I have to find y. So shouldn't I plug x equals 9 into one of these equations up here? Yep, and let's do the top one because it doesn't really matter. -4, I'm rewriting the top equation, but instead of putting in x, I'm putting in 9. -4 times 9 plus 9y, that's supposed to say y, equals 9. -4 times 9 is -36 plus 9y equals 9. Add 36 to both sides. 9y equals 45. Divide 9. And y equals 5. So, if x was 9 and y is 5, then my final answer is the point 9, 5. Dolly Parton. That was the worst circle I've ever made in my entire life. Thanks, lag. Can I move this circle and try again? Yes. If at first you don't succeed, dust yourself off and try it again. Try it again. You could dust it off and try it again. That's a song from the 90s. All right, so that was solving systems of equations. What if I ask you to do something different, like solve systems of inequalities? Easy. You know how to graph this. You know how to graph it. So let's graph it. It's green. Start at -2. Put a dot. My slope is -1. So up one, left one, 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 up. Oh, I ran out of room. Down one, right one, down one, right one, down one, right one. It's less than or equal to, so I actually fill in the whole line. Less than or equal to means you fill in the whole line. If it was just less than, I would make it a dashed line. Since it's less than or equal to, I shade underneath. Oh, this is a lot more fun than what we just did. So are you to tell me that if I have two of them to graph on one graph, that I just graph both of them on the same thing and see where the two colors meet? Yup, it's that easy. Let's graph this one. Put a dot where the 2 is. The slope is -5, which is up 1, 2, 3, 4, 5. Ran out of room. Down 1, 2, 3, 4, 5. Right 1. Put a dot there. Down 1, 2, 3. Ran out of room. Draw a line as best you can. It's hard drawing a line on a computer screen. Not gonna lie. This one has me greater than or equal to, so I'm going to shade above. And I know it's hard to see, but above is here. You have to view it as like if I'm climbing a mountain, where would I walk if you're above? And it's a steep mountain. Now, this is the last part, and it's really easy. Your final answer is going to be the color or the area where the red and the green meet. And that happens right here. So the blue is my final answer, that tiny, 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 tiny little space is where my two lines and my two shades intersect. And what I'm going to do is I'm going to put a little arrow there, and I'm going to put an R, because it's called a feasible region, and most books or most teachers use an R to represent your final region, and I'm not going to change that. I'm going to do it just like that, baby. So if I'm graphing inequalities on a coordinate plane, I shade in as many things as I have to shade in, and wherever my two colors meet is going to be my final answer. Google Meet. Meat sandwich. Meet the parents. Let's do this. This is much worse. I'm going to do all of this in blue. Let me go off to the side. I have to get y all by itself. Oh, poop. Oh, poop. Let me see. Is y all by itself? No. What is in the way? Well, I'm going to have to subtract 3x from both sides. Minus 3x. That gives me 2y is greater than or equal to negative 3x minus 2. Is y all by itself? No. 2's in the way. Divide everything by 2, divide everything by 2, divide everything by 2. And when I do that, I get a final equation of y is greater than or equal to negative 3 over 2x. 2 divided by 2 is 1, so minus 1. So that's my top equation. So let's graph that, John. I'm going to start at negative 1. And I'm going to go up 1, 2, 3, left 1, 2. Boop. Up 1, 2, 3, left 1, 2. Boop. Or I'm going to go back to that original dot and go down 1, 2, 3, right 2. Boop. Should I dash this or should I make it a solid line? I'm going to make it a solid line because the line that I have is greater than or equal to. And not just greater than. Am I filling above the mountain or below the mountain? Above the mountain because it's greater than or equal to. Good job, everybody. Good job watching. Let's do the bottom one in purple. I have x plus 2y is less than or equal to 2. Is y all by itself? No. Minus x. So that leaves me with 2y is less than negative x plus 2. Divide everything by 2. Divide that invisible negative 1 by 2. Divide by 2. Cross you out. Y is less than or equal to negative invisible 1 over 2, or negative a half. X. 2 divided by 2 is 1. So there's my other equation that I have to graph. So start at 1. My slope is negative 1 over 2, so up 1, left 2. Up 1, left 2. Go back to my original dot. Down 1, right 2. Bing. Down 1, right 2. Bing. I drew as many dots as I could. Draw yourself a nice little line. Oh boy. And I'm going to shade below because this is less than. So the part that's shaded is down here. Ooh, look at the purple and the blue meet. So wherever the purple and the blue meet is my final answer that I'm going to color in with green. So my final answer is going to be this green area that I am now coloring in. That's taking its sweet old time because it just is taking a while. But that area right there in green is my final answer. What this means is any dot that I were to plug into the equations that's in this green region is a possible answer. And R for region. All right, so let's take a look at the kitty cat problem here. I have a shaded region where, let's just start out with that dashed line there. This dashed line is dashed, which means there's no or equal to component, so that's that. It starts at 1 and goes up 1, right 1, up 1, right 1. So this equation right here is y equals, it's shaded below that dashed line, so it's less than. The slope is up 1, right 1, so the slope is 1, invisible 1, x, and it started out at 1. So that's my one equation. So I can get rid of u, and I can get rid of u. Now let's do the other equation. The other equation has a slope of 0. So it goes right through 2. So y blah, 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 negative 2. I'm shading above, so that equation is going to be greater than, which means that it can't be u, and it has to be u. It has to be u. All right, so that's the end of section 4, chapter 0. Lots and lots and lots of systems of inequations or inequalities and equations. That's that.